My name is Ben Schonberger. I am a planner with Winterbrook Planning and a member of the board of Housing Land Advocates. I first just want to shout out Winterbrook as a sponsor of this conference, my employer, and we are a land use and environmental planning firm. We're doing good work both on housing and on other things all over the state. Come and talk to us. We're mostly over there. To that end, the next panel that I'll be moderating is getting into bricks and mortar. I thought it would be good for us to have a panel that provides a little bit of a counterbalance to some of the other topics and what's honestly more familiar to many of us here in what we do. That is, we, and I guess maybe I'm saying I, deal in a lot of reports and law and emails and policy decisions and less so the actual concrete and insulation and air conditioning units and the things that are sort of at the end of the housing process of all the reports and emails that we write. I once did a take your kid to work day, and I brought my son, and he thought I was extremely boring because I just sat in front of a computer and wrote emails and talked on the phone every once in a while. But there are people out there who are pouring forms, are building forms for pouring concrete and making decisions about which building materials to use and which of those things has less of an impact on the climate. So we think of buildings as sort of downstream effects of all these plans and legal cases, but the decisions about those buildings are extremely important to the climate, and the choices that people make have very different impacts. So to that end, we invited three experts to discuss what we'll think of as actual physical changes to the built environment, housing in particular, and how those changes affect or are affected by the climate. So thinking about it another way, what kind of actions do housing actors in government and in industry take that both or either reduce climate impacts or adapt to climate impacts? So with that as our lens, each of our three panelists has a really interesting story to tell about some piece of the housing world. So to go through who these people are, Becky Steckler, AICP, is a project director at ECONorthwest, which is a Portland-based consulting firm. Since rejoining ECO in 2022, she's worked on numerous projects related to adaptation and resiliency in the built and natural environments. So she's going to speak about a recent study that she led with the city of Portland about the cost of decarbonizing buildings. Rita Haberman is a built environment specialist for the Oregon Department of Environmental Quality. Rita has actually a fascinating work history when I looked into this intro in nonprofits, consulting, and in government. She co-founded Willamette Riverkeeper, which is great. Yeah, hooray. And she also had a stint with the Rebuilding Center, which is another organization that I love. And she now works for Oregon DEQ. And as a built environment specialist, that's exactly what we need for this panel. She's going to talk about embodied carbon in buildings. Eric Foley is a senior manager of multifamily programs at Earth Advantage. Earth Advantage on their website describes part of what they do as partners with entities across the country to develop tangible systemic solutions for climate-friendly housing. So also exactly on point. He manages green building certification services for multifamily housing at Earth Advantage, and he'll speak on the issue of resiliency in housing. So I'm delighted to have all three panelists here today. So we will lead things off with Becky Steckler.
Thank you. I had the opportunity to really be able to dive in a little bit deeper with the city of Portland to think about, even before you start to, grab a hammer or really kind of impact your housing, to be able to ask the question, how much is this thing that I want to do going to cost, and what are the implications of this for rents? And so if you want to go to the next slide. We worked in 2024 with the Portland's Bureau of Planning and Sustainability, and they are in the process of thinking about how to reduce emissions from existing buildings, and also thinking a little bit about new construction of single-family and multifamily housing. And so they asked us to help them think about three different kinds of policy questions. So the first one was around carbon performance standards for those large buildings. And as they were kind of thinking about, what are the different trade-offs for how they could be setting those emission policies and targets, and really what are the anticipated costs to the property owners that would have to make their buildings more energy efficient, and then ultimately how would those costs potentially be passed on to renters, especially naturally occurring affordable housing renters that are in that kind of housing. On the other side, so that's building decarbonization. They're also thinking about a cooling temperature standards. That's more adaptation I'm going to talk about. And that is thinking about what would having a cooling requirement, what would it cost property owners and renters? And then we did a little bit of kind of background work as well, thinking about in new construction, what are the differences in costs between gas, kind of a mixed gas and electric, kind of a conventional all electric, and then a high efficiency all electric. And so in all these ways, you start to think about how can we make our housing much more resilient? Next slide. And so there's a reason you pay attention to buildings. And the city is starting by paying attention to those buildings that are over 20,000 square feet. So buildings make up about 40% of all emissions in the city of Portland. And for those large buildings, there are about 14, a little less than 1,400 large buildings. And so large multifamily, large office, large commercial, thinking of schools, hotels, hospitals, things of that nature. And so it's really kind of the low hanging fruit. They represent about just under half of all emissions from buildings themselves, but you have to deal with fewer property owners. So you can really have a pretty big impact by targeting some of those properties first. Then you can start thinking about all the single family homes. Next slide. And so, and of course, you're not really working in a vacuum. The Oregon legislature passed House Bill 2021, and that is the Oregon Clean Energy Targets. And so this bill requires Portland General Electric and Pacific Power to reduce their emission levels to about 80% below a baseline by 2030 and 100% by 2040. So there's a lot of decarbonization that's happening kind of within the energy sector. And so we also wanted to understand just how much more would you have to get from the buildings themselves. And so for the city of Portland, we looked at not just multifamily, but we were also looking at office buildings. And through this analysis, we determined that you would need to reduce emissions by about 1 kilogram per CO2 equivalent per square foot. There was a measurable that we had to get to really understand what are the potential costs on the other side. Next slide. And so we looked at, and I wanted to say too that we worked with ZGF architects and PAE electrical and mechanical engineers and DCW cost estimators, really to make sure that we understood what do you have to do with existing, primarily multifamily, I'm going to talk about today, to get the kind of reductions in carbon emissions and to be able to estimate some of those costs. And as you can probably guess, there is a really wide range of building types and conditions throughout the city of Portland. And so we were looking at things like, what about lighting and plug loads, the building envelope improvements, insulation, ceiling, kind of things like that, as well as water heating, air heating, cooking, what are all the different things that you could potentially upgrade within a building. And then actually we wanted to make it as specific to the city of Portland as possible. So we looked at the building stock and when were buildings actually built. And we were able to kind of, looking at all that, really be able to start to categorize different types of buildings that would be some that would need kind of more intensive investments and some that would need less intensive investments. So in that kind of 20 to 50,000 square foot property category, it's where you find most of your smaller and older properties. They were built mostly in the 1960s and 1970s. So you can imagine what kind of building codes were in place at that time. They tend to be more affordable, and that's where you see kind of more of your typical naturally occurring affordable housing. With the larger and newer properties, that's in the 50,000 to 100,000 square foot range, approximately. Those were built kind of a more average age is built right around, I think, on average around 2009. Many of those really large multifamily properties have been built, within the last 10 to 15 years. So building codes are a lot different, and so their kind of energy profile is much different as well. So the amount of investment you have to make, they're already very energy efficient. And so kind of what that all comes down to too is often it is not enough to just put a new appliance in, and especially if you're looking at a heat pump. Many of those older properties need electrical panel upgrades. They might need venting. It gets really complex really quick, and there's so much variability. It was a bit tough, and we had to come up with some prototypes to kind of play through what would this potentially look like on a kind of a prototypical type of a building. The other things I wanted to say here is that, so for those roughly 450 multifamily rental properties, there's about 15,000 rental units. And in that kind of smaller, older property category, we identified about $152 million worth of investments and only about $3 million in those newer buildings, which just really reflects kind of the scale of investment that would be needed to be able to hit those carbon reduction standards. Next slide. And then finally, I did want to touch on the, what does this mean for rents? And, many property owners are going to want to pass on the cost of these investments. And we also looked at, back in even the fall of 2024, the environment and the outlook for incentives, both in the federal Inflation Reduction Act and the Portland Clean Energy Fund and other kind of state incentives were very positive. And it looks a little bit dimmer, I would say, from my seat today. But so there's still, we were looking at both kind of what would the overall cost be, what are the potential incentives, what would the gap be that then might need to be filled, and what does that start to look like? And one of the things that was clear here is that the rental market is a competitive market. Landlords are competing for different renters, and depending on how tight that market is, they have more or less leverage. There's a lot of individual players that are making decisions. They're not exactly coordinated with each other. And so they've got to determine how much they might potentially increase those rents. If this is a requirement that's across the city, then that amenity might not be seen as an important value that or an important amenity that renters are saying, I'm going to pay a little bit more so that I can make sure that I get that heat pump or not. There's just not as much evidence out there to back that up. And that said, if it is, say, a heat pump or something that could potentially reduce utility bills, then you might see, and basically it was like that kind of potential rent increase might be roughly the same as the savings that renters would get from any kind of energy efficiency appliances that were then installed. Next slide. I don't know if you remember 1920 or 1920. Do you remember 1921? I hope you don't. 2021. It both seems like it was just yesterday and a really long time ago. That June, I actually celebrated my birthday during the heat wave on that 112-degree day. And it still feels very shocking to me to remember like what that felt like. Next slide. And The thing that, as I've watched other heat waves kind of go across the country, and which is always a good reminder, is that when there are heat waves, people die. And the people that more often die are older adults that are living at home, that are often income restricted, lower income, uh, and um, they die because people aren't checking in with them, or even if they have a way to cool their house or where they're staying, if they do have an air conditioner, that air conditioner might only reduce the temperature by about 20 degrees. Or they might be really worried about how much it's going to cost to run that air conditioner as much as they should. With these higher heat waves, also, it doesn't cool down as much at night. And so that adds additional stress to people who are living through it. And of course, it's even hotter in so many of the low income areas across the country, up to 5 degrees. And those are not only low income, but often places where people of color are living. And so it's always a good reminder to understand exactly, why it's important to think about the health implications of our housing policies and climate related policies. Next slide. So many more cities and communities across the country are thinking about um, a cooling standard. And most right now have a minimum, like a heating standard. So you can't rent an ice box. Landlords have to provide a furnace or something so you can heat up your unit and be comfortable where you live. And so now with some of these like extreme heat waves that we've seen, they're also saying, what about a ceiling? Can we make sure that people can reduce the temperature in their home to something that they can survive? And so you've seen some of these definitely in Arizona, actually Maryland, California has some other requirements as well. Next slide. And so here we looked, the city of Portland has about 153,000 rental units. And of those, about 75% actually have some kind of way to cool some kind of air conditioning. The Portland Clean Energy Fund's Cooling Portland program is on target to install another about 15,000 cooling units. But even when that is in place, there's going to be about 25, almost 2,500 rental units that do not have any kind of air conditioning abilities. And so we, again, kind of looked at some prototypes to try to figure out how much would it cost to put some kind of either at the very low end, some air conditioning, a unit you could just put into, your house, as well as all the way up to a mini split heat pump that likely would also require, kind of looked at all the way through there, whether or not it would require electrical upgrades and other kinds of mechanical upgrades to be able to install it. And so, and it's split there's three prototypes. The single family home that typically for rental homes was built before 1940. That small multifamily that looked like what I had described before, built in the 1960s or 70s, naturally occurring affordable housing, on average about 18 units, and a little just shy of 900 square feet. And then the large multifamily that has a property that has over 70 units and was probably built right around 2010. And we used NREL, the National Renewable Energy Lab has some great calculators and other tools to help to determine like what emissions might be from these, and energy use. And then one of the things, being very conscious of cost, the city also wanted to understand, what if you just provided a space or required a space within a building that could be cooled, so some kind of common space, or if you had to provide cooling for every single unit. So looking at kind of what are all the different options that you could really do to encourage the healthier outcomes. And especially when thinking about window AC units, it's not as uh, desirable necessarily by property owners. It's easier for it to walk away. But if something's installed, it tends to stay with the property and it becomes kind of that amenity for the property itself. Also, mini splits or any kind of heat pump is also going to reduce utility costs, which is a benefit for cash-strapped renters, as well as reduce emissions. And so being able to get to some of those, some of those other goals, but it definitely costs a lot more. So that's of concern as well. And so just looking at this particular slide, I realized yesterday that this is basically the gap cost. We did include when we were doing the analysis, both the total cost, which was much greater, and then when you apply what we assumed would be available with the Inflation Reduction Act and some of the PSEF funding and other kind of state funding. So the actual cost is a bit more than this, but we did identify that there's still from the very low and common spaces about 1.4 million for just window AC units, and then up to almost 40 million for that mini split heat pumps. And then in unit, it's anywhere from a little less than 8 million to up to $50 million for those 25,000 plus units. Next slide. The final bit of analysis that we did, which was super interesting as well, is just, wanting to be able to compare what does it cost if you had an all gas, either single family or multifamily home, a kind of a mixed, because of course, so many of us have a combination of maybe an electric stove, but a gas heater or some kind of combination of different sources of energy. What about a conventional all electric? And so I would say that's kind of your lower cost electric appliances, base wall-based heating, electric heater or water heater, kind of things of that nature, and then a high efficiency all electric. And both looking at it at the installation or kind of upfront construction costs, and this is for new construction versus, and then considering the operating costs over roughly a 15-year period, just to have a better understanding of what kind of that total cost might be. And so looking at single family, we were comparing basically the electric to the gas costs, and gas was more expensive. And while conventional electric was cheaper to build, definitely the high efficiency, it basically broke even once you got to that 15-year mark. And so you got that, you can see that return on investment. Next slide. We also looked at multifamily buildings, and it's a bit more complex just with the way that buildings go together and the kind of piping and other related elements to that. And but again, and I just want to put the caveat: it's pretty rare to have a all gas multifamily apartment building or really property, because it is so much more expensive, and so you almost never see it. So that's one of the reasons we included the mixed heat, and definitely property developers are looking for sometimes some of the least cost, but still having the amenities that people care about. And you see a lot of air conditioned units, especially in the newer in that kind of new construction building. Conventional all electric is almost, roughly the same cost as that mixed heating. And the high efficiency is a bit more. Basically, the high efficiency construction costs were between $12,000 and $15,000 more than kind of that conventional electric cost. And you save about $5,700 in operating costs over the 15 years, but it's not quite enough to really make up for that initial upfront cost in multifamily homes. And with that, you don't have to take, next slide. You don't have to take my word for it. If you want to read any of these reports, you can download them from the City of Portland's website. And there's more information about building the decarbonization efforts that you can find there as well. Thank you.
Hi, everybody. My name's Rita Haberman. I'm a built environment specialist with Oregon DEQ. And I'm going to share with you information about embodied carbon. What is it? Why should we care about it? And what can we do about it? What are we doing about it? What can we do about it? Next slide, please. Before I dive in, you might be wondering, why is DEQ working in the built environment? DEQ regulates my tailpipe emissions and polluters and promotes recycling. Yeah, DEQ does that. And more than 10 years ago, DEQ embarked upon a strategic plan. And what differentiated that strategic planning effort from those prior was that DEQ really took a life cycle perspective on the materials that we use, everything from our building products to appliances and furniture, everything. What we learned when we took that life cycle perspective is that the lion's share of the impacts of the materials that we use and products that we use, those impacts are upstream in the manufacturing process, not at the end of life at disposal, where DEQ, before that strategic planning process, DEQ's program was called Solid Waste and Recycling. Now we're in the business of materials management, meaning really thinking about all those life cycle impacts over the course of the life cycle of a product or a material. Taking that perspective also helped us realize that the built environment has a huge impact on our environment, our natural environment. It also has a huge impact on our social environment and equity or lack thereof. Next slide, please. First, I just want to level set a little bit. I think a lot of folks are probably familiar with what the term embodied carbon is, but I think it's still a little bit new. Embodied carbon is all of the emissions that are associated with a product from the beginning, if you will, from material extraction, production, manufacturing, transportation, all of those, all that energy that takes to produce materials. We're trying to quantify that and recognize that and acknowledge that. So let's use an example. One very, very commonly used building material is concrete. And we might think, well, concrete, that's pretty basic. That's, got some rocks, got sand, got water. Those are all locally sourced and not really processed. But another ingredient of concrete is cement. And cement has a huge impact. In order to produce cement, limestone and clay get heated to around 3,000 degrees Fahrenheit. That's a really hot pizza oven. It takes a lot of energy, obviously, to heat those production facilities. And then there's also a lot of off-gassing, a chemical reaction that takes place that also kicks out a lot of CO2. So concrete is one of the most carbon-intensive materials that we use, and we use a lot of it. So I just use that as an example to kind of highlight embodied carbon. Next slide, please. When we, it's not just concrete and cement that have the majority of their impacts upstream in production. In general, for all building products, and there's some exceptions, but a lot of building products, roughly 90% of their impacts are upstream in that manufacturing and production. Next slide, please. When we apply a life cycle perspective to our buildings, meaning thinking about what are the energy inputs and uses from the time of construction through decades of operation, we realize that there's a huge impact up front. And that upfront impact is all the embodied carbon that's associated with the materials that we use to build our buildings. And then over the lifespan of our buildings, we'll have some periodic renovations and upgrades. So on this graph, the yellow bars are embodied carbon, big up front, and then some blips, if you will, over the life of the building. The blue bars are operational carbon, the amount of energy that we use to heat, cool, ventilate, light our buildings. And as Becky was noting, our grid is getting greener. So our operational load, whether we do anything in the specific building, it's going to go down because our grid is getting greener. But my point here is that as our buildings get more energy efficient, the operational carbon impact of our buildings is decreasing. The remaining piece of the puzzle that we still need to address is the embodied carbon impacts of our buildings associated with our materials. Next slide. As a society, we have focused a lot on energy efficiency with huge success. This is kind of a busy graph, but it's basically normalizes the EUI, or the energy usage intensity of our buildings over time. And as you can see, it's gone down significantly. If we build a building today just to meet current energy efficiency code standards, that building is going to use half of the energy of a code-built building, a comparable code-built building 50 years ago. So my point here is, when we focus on issues, we can do amazing work. If we don't focus on them, we're in trouble. So one of the things we're working on at DEQ is supporting the Building Codes Division and other players to explore the integration of embodied carbon limits within our building code, just like we have energy efficiency within our building code. Codes work. Next. So how do we measure, how do we quantify embodied carbon? This can get really, really complex, but in its shortest terms, in its simplest terms, it's done through a really rigorous accounting methodology based on ISO standards. Think about what goes into it, what goes out. It's very, very rigorous. And the results of it, for the purposes of building products and other products, get spit out into a report that's referred to as an environmental product declaration, or an EPD. Think of an EPD, environmental product declaration. It's really analogous to a nutritional label. With an EPD, we can compare the embodied carbon or a global warming potential of different sheetrock products, just like we can compare the different caloric characteristics of different ice cream. So it's really a label to help inform our procurement. Next slide, please. The embodied carbon emissions of our building materials, of those that we use throughout the state of Oregon, account for more than 14% of our combustion-based greenhouse gas impacts. That's a pretty big slice of the pie. If we add to that the operational carbon impacts of our building, which is ironically is also around 14% now, our buildings account for more than 1/4 of our greenhouse gas impacts throughout the state of Oregon. So that's a big chunk of the pie, and an area to focus on. Again, so what do we do about it? Well, one thing we are doing about it is we need to assess and quantify and disclose those impacts of our building products. We need to help manufacturers will help and nudge manufacturers to do the life cycle assessments of their products and disclose those carbon impacts. Last summer, DEQ partnered with our sister agency in the state of Washington Department of Commerce, as well as International Code Council. And we pursued some funding from US EPA specifically to do that, to help manufacturers of building products that are serving our region, help them do that life cycle assessment and produce those EPDs. That's kind of step one. Unfortunately, this grant did not get through contract execution before January 20th this year. So this program is in limbo. We haven't formally heard yet whether it's stalled out indefinitely and dead. We're still holding out a little bit of hope because there's a lot of manufacturers who were also awarded these grant funds to do this work. So anyway, it's an important tool and important strategy. Next slide. Another thing we're doing is we pursued many buckets of EPA funding while the getting was good. And last summer, the state of Oregon secured just shy of $200 million, again from EPA, in a program that's called Climate Pollution Reduction Grants. And this was a joint effort with the governor's office, Oregon Department of Energy, and some other partners to implement 12 priority strategic climate actions, including some related to housing. Approximately 25 million of the 200 million is specifically for housing. Next slide, please. So more specifically, the 25 million that I mentioned is going to be used to incentivize two different low carbon housing strategies. The first one is adaptive reuse of underutilized existing buildings and convert those to housing. The potential for this is significant. It's no surprise to a lot of us who run around Portland. Approximately 1/3 of Portland downtown office buildings, I know the number fluctuates, but let's just say, 1/4 to 1/3 are vacant. But it's not just big Portland metropolitan area. There's a lot of opportunity in small town Oregon as well. University of Oregon and Oregon Parks did a study a few years ago and found that roughly half of the spaces, the second-story spaces on main streets, you name your main street, and you'll notice it as you pay a little more attention. There's second-story spaces above retail. About half of those are underutilized, are vacant. The second strategy is one that I think is very familiar for many folks here, and that is just space-efficient, right-sized housing, or the missing middle. ADUs, duplexes, townhouses, and so forth. Next slide. We're focused on these two strategies, building reuse and space-efficient new housing, because they are by nature low carbon. Both of these strategies require less materials to build. Smaller spaces take less energy to heat and cool, ventilate, and light. Smaller spaces also provide less space for all our stuff. Our stuff is a big part of our climate problem. We have an overconsumption problem. Do we all need 2 vehicles, a lawnmower, an extension ladder? We don't all need that stuff, and 3 couches for 3 rooms we don't even use. So that's part of the puzzle, but we'll save that one for another time. And another thing is Again, this is something that this group knows very well. It's not just about building housing. It's really important about where we build it, right? Both of these strategies are conducive to development in already developed areas, infill, which gives us the opportunity to use existing infrastructure and get around that barrier. Personally, I think one of the most interesting aspects of this are the co-benefits, which is kind of a sterile term for some of the most important, meaningful stuff. Like, I mean, we have an opportunity to revitalize, reactivate some of our downtown areas. We have an opportunity to provide more walkable lifestyles. And someone else mentioned this earlier, but we're so dependent on our vehicles. Well, if we're really focused on that infill, we can reduce a lot of those impacts. They're noteworthy. So the way we're going to get these $25 million out the door is we're partnering with 9 local governments throughout the state, including the city of Bend and Rachel and her team. Local governments are playing the role of boots on the ground, if you will. They're helping us with the outreach, getting the word out, and they're also going to be helping us with on-site verification to help us, verify the projects. And DEQ is playing more of a higher level coordination. We're putting together tools and resources, and we will be interfacing with US EPA. When it's all said and done, over the course of the 4-year implementation period, we're anticipating we'll have 900 new housing units that'll be workforce and affordable housing. And I should mention that these are EPA funds coming from the Inflation Reduction Act, and it's been a really, really interesting last several weeks with the spigot going on and off with regard to funding. At the moment, it's on, so we are forging ahead as quickly as we can, but it's been an extremely tumultuous last several weeks here. Next slide. In addition to building reuse and building smaller, another opportunity related to reducing the impact of housing is the informed selection of the materials that we use to select more lower embodied carbon materials. Some really cool research has come out of Canada, Rocky Mountain Institute, and some partners. The takeaway here is there's a relatively limited list of product categories that account for the lion's share of the impact. So we don't need to be, looking at nails and screws and door hardware and, too many details. We can focus on a handful of product categories, like concrete, insulation, exterior cladding, sheetrock, and flooring. If we just focused on those material categories and we used environmental product declarations associated with those products, we can reduce the impact significantly, 30%, 50%, just by making more informed choices. So if embodied carbon is of any interest to you, I strongly encourage you to check out some resources. The Carbon Leadership Forum, CLF, top notch, just incredible research. They're serving all of us. They put together some incredible educational resources that we at DEQ use all the time. Architecture 2030 is another really helpful resource. And then DEQ is going to be putting together technical assistance resources to help housing projects that are part of the grant program that I mentioned. Next slide. And I also just want to mention from a policy perspective, DEQ is in really good company in terms of others who are putting energy and efforts into reducing embodied carbon impacts. Up and down the West Coast here, there's a lot of notable state and local initiatives. And I will not talk through each of these, but my point is there's a lot of momentum in this arena. But one of the efforts that I just want to call out is Oregon Building Codes Division last year. They did a study of the potential of including embodied carbon limits within building code, and they completed that study and analysis, which DEQ supported them in that effort. They issued that in December, right before the end of the year. We see that as very, very promising, and I call it out because it might be coming down the pike, and it might be something that you might be interested in checking out. And in closing, wrap it up, recap, embodied carbon is a huge issue. It's part of our climate action puzzle. There's a lot of good references and resources and tools already available that can be implemented at cost neutrality or very, very minimal cost premium. And again, I'm going to make a plug for the incredible resources that the folks at the Carbon Leadership Forum have developed. Thank you. I'm going to pass it to Eric.
I'm gonna focus my my wave of connection because I've got this presentation has a fair amount of click throughs, but we'll be on the same page here. My name is Eric Foley with Earth Advantage. I'm excited to talk with you all today. I'm just going to give you a little background about me, and then we'll tell the little arc of the discussion I'm going to be talking about. So, when I started my career, I actually started as a banker financing startup companies. And then I pivoted into real estate, which was my passion. When I was 5, I went to my first property with my grandma. We talked ourselves into a property, and it got the bug in my ear, and I just wanted to go back into that world. I pivoted into construction, and I was working on senior and affordable housing and doing affordable housing upgrades on those properties. And then after that, I've been doing 15 years of consulting work. 13 of those have been with Earth Advantage. So Earth Advantage was my first nonprofit, and I love it. And I love the work we do. I work with a lot of affordable housing projects. And so that gives you a little bit. So this discussion is going to talk about financing stuff of impacts and investment, and also talks about the practical applications of resiliency in those worlds. So Earth Advantage, we're a nonprofit. We are focused on housing and solutions for housing. We've got workforce training. We've got certification services. We have tools that help people inform and make informed decisions. And so a lot of the stuff we do today and in the future is all about training people up and understanding the impacts. I'm also a gadget guy. So I like to bring tools with me to help inform people about things you can't see. So we talked about CO2. And so this space is fairly large and it's probably going to be okay. When you're outside, levels of CO2 are about 400. When you're in a really stuffy space, and hopefully none of us are boring you, that space gets really high. 2 years ago, when I was presenting with the state resiliency officer in a very poorly ventilated space, we got so tired and stuffy that we almost fainted. Fortunately, the levels are pretty good today, but these tools are really helpful for us to be able to provide information about things you can't see, but you feel as a person. And we're trying to make that informed decision about stuff for you all. All right, so why resiliency matters. I've got a statement up here that talks about kind of the people we're working with, those unhoused and housed folks that need to have solutions for them, and how those have impacts not only on their stability, but also reducing their financial burdens. These are things that we're all kind of focused on and how we can make those solutions possible. And now we're going to start working through this kind of thing. And I'll do a lead up here. And there's a Pew study that was done on if you're doing pre-disaster adaptability on designs versus the post-disaster impacts, that's 1 to 6 or 600% or 6 times investment. So these are really smart solutions, and why it really matters for us to make these types of investment dollars, because we're really saving on a financial basis, let alone impacting people and the people of those communities. Housing, that has, in terms of long-term maintenance, up to 30% of reductions through durable materials like embodied carbon and other things that we're working through in passive designs and smart infrastructure. These are all really important things that we have in terms of those impacts. And then in terms of, this is also shared recently with various things, reduction of utility bills, which we know that when you get into a house, it's not just the cost of rent, but it's also the utilities that you spend on those to be able to maintain and live in those spaces. And sometimes when those utility costs go too high, you are maybe forced out of housing. And so these are really important things to be able to keep those things low. All right, so this is going to be a click through. We're looking at the various types of things in terms of adapting to, recovering, and various adverse events. And so these are just different things that we have that we're looking through on those fronts. So natural disasters, climate extremes, utility outages, health and safety, community well-being, and long-term viability. And now we're looking at, what are the objectives here, right? As we're looking at these types of stuff for resiliency, there's kind of two primary ones in my mind. And so the first one is that duration. So we think about in terms of life safety and then also sheltering in place as the main topics when we bring and giving those discussions in eco-charrettes and advising various building professionals, the development communities and designers and the builders and the occupants. We also think about the goals. So we need to prepare for those, the duration and the services that are tied to those types of spaces. So here's going to span out a little bit in terms of the financial implications here. So 2 years ago, when I gave a presentation on resiliency, the number in 2022 this is a reinsurer on a global basis, one of the largest outfits that does so from Munich RE. That number was $270 billion. And in 2024, that number had grown to $320 billion of financial impacts on a worldwide basis. And when you bring that into the US alone, in 2022, it was $23 billion or larger events. And in 2024, $27 billion events or larger. 60% of that cost, that $320 billion, is from North America. So we've got a large impact in terms of the infrastructure and about buildings and stuff that are happening from all these different types of events around the world and also locally in our communities. And then this was also discussed in terms of those heat waves that we had. But if you look at it from the pre-industrial to the current times, we've had the two largest heat impacts. It's gone 1.5 C, or for those in Fahrenheit. I work in both. My partner is from a foreign country originally. That's 35 degrees Celsius of average temperatures have grown over that time frame. So we're really living in the hottest times that we know, and we're having to adapt to those types of climates. So now we're going to move into the practical side of things. So I like to use the oak tree as my kind of metaphor of resiliency. And that oak tree is only able to thrive and survive through the roots. So that's the next, it's going to be a lot of click-throughs here. But we're thinking about that in terms of not just the main, we talk about the community, the different types of surrounding people relying on one another. And so we have to think about it as the ecosystem of, you are not just relying on yourselves, but you're relying on those neighbors around you, especially when disaster is happening. So location, transportation, infrastructure, we're looking at those passive survivability and structural durability and mitigations. We're looking at the on-site renewables and storage. And then we're keep on moving through here. There's a lot of clicks. I know the natural lights and also those operations affordability. Okay, so when I talk about sustainability and resiliency factions, I talk about passive survivability first. So we want to think about the infrastructure, the building itself, how is it able to survive through the means within itself, not through mechanical means, not through other types of utilities, because when natural disaster happens, most of those things, that infrastructure is going to get probably lost. And so you have to think about the building itself, how you can survive in that space and how you can be able to help one another in your community. Then you move on to the next kind of phase, which is lowering that energy through kind of efficient systems. It's like HVAC and domestic hot water. We know that water is about 30% of the energy cost of a building, kind of in terms of that overall footprint. We think about air quality. A lot of us probably saw and felt the forest fires are seemingly growing in our markets. This is a nationwide basis. And so air quality really matters in terms of the solutions we're thinking about filtration and how we're keeping those spaces clean. There are some cool study details, and I've got a pamphlet that I have available if anyone has interest, and we can provide later. But there's a thing where you have MERV filters and a box fan. You put that together, and it provides filtration of your space on a temporary basis if you don't have the infrastructure in your building already. Now we move on to on-site storage, so renewables and battery operations. That's for the microgrids and the peak loads and all these other types of things that we're shifting that type of energy load and how we're able to work through that pace. And then for the business that I do and the things, we're talking about the sustainability initiatives. So third-party certifications, we're a guide for people working through that. I work through projects like Lead for Homes, Earth Advantage, Enterprise Green Communities, Energy Star, Passive House. These certifications are both on a local, regional, national basis, and those provide access to debt, equity, capital, tax credits, incentives that help people make these improvements on their properties and move them towards a better solution. We also need to think about commissioning and recommissioning of those buildings, because if the equipment's not functioning properly, then it won't be able to function for what you're expecting of that building. You may have great building materials, you may have great equipment, but if it doesn't work right, then are you actually providing an equitable solution for the residents? And the last piece here, which is planning and training. So, having a plan that allows you to get through kind of those systems, training up on different things. What do you do? PBEM and other agencies have like Beacon and Net as solutions for training you on what you can do and how you can survive before FEMA can come in and help you with survivability. These are all really important things. We've got a lot of different types of natural disasters. Obviously, we're on the subduction zone, but we're going to eventually have the big earthquake here. We've got forest fires. We've got heat waves. There's just a lot of things we have to kind of take into consideration. Right. So now giving that kind of that set example, I want to talk now about several of the affordable housing organizations. And there was too many to choose from. I know I've seen a couple of affordable housing developers here, and it was hard to choose because everybody's doing really great work. So I just picked a couple to just share a little story about. So the first one here, they do all of those things in terms of the, shell, the efficiencies of equipment, the having a plan, working through a sustainability, thinking about those things. But this particular developer, CCC, they did a concept what I call hub and spoke or node or web. And so there are 3 buildings that are on division between 112th and 114th. They're neighbors of one another. They have the ability to both be civilian or resilient within the organization or that building, but also they have the ability to rely on the services of the adjacent property to provide that better kind of connection. And then a 35-minute walk, which seems like a lot, but when there's a natural disaster happening, you've got a hub, which is the Blackburn Center. And that has medical facility and other types of services that can rely on one another to help these buildings with the efficiency. There's a lot of cool things on here. This is kind of a takeaway slide of sorts. So there's a lot to digest in this particular thing, but they've got renewables and they've got high efficiency equipment and filtrations and other types of cool things that allow the building to operate in natural disasters and be adaptable to the environment. The next developer is Hacienda in the Coley neighborhood, Las Adelitas, taking back that space, and it's really a vibrant community now. They got a lot of input from the residents before they went through that process to make certain that that space was going to be viable for them. The facility for headquarters for Hacienda is next door. So once again, this kind of connection to one another, but they're also looking at future-proofing their buildings. So they did an initiative called Mi Casa, and there's 6 properties, about 1,000 units, and they're doing retrofit upgrades to those properties to once again provide cooling and other types of electrification, other things that will help that building and those communities, as well as some of the upgrades here they're doing in terms of all electric and some really cool initiatives to address not just kind of the today, but also to tomorrow. We're thinking about what the long-term effects. These buildings are intended to live for generations. They're not as meant to be derelict in about a 10 to 20 year period. So the designs and initiatives that we're all doing together is thinking about that longer horizon. And the last project here is as a BIPOC communities, senior housing. It's in the North Portland area. It's currently just finishing up design. It's going to be going into development for M. Carter Commons. The concept here is we call this one a nest approach. So if you don't have the funds to be able to create a solution for the entire building, then you center the funds on maybe the community space, and you really amp up some of the systems in that so that the residents have a place to go to provide a little bit better shelter during those kind of inclement weather patterns, and then be able to rely on those. This one's also going for Earth Advantage certification along with some federal tax funds. We'll see if those hold. As far as we understand, they are right now through the 45L tax credits. That's the Energy Star and the DOZER programs. So these are also things that are able to layer on that capital stack and allow those projects to proceed forward with all of these great initiatives. Okay, so my call to action to you all is that we need to not just think about resiliency as a feature, but we have to really kind of expand our ideas about the foundation of that for affordability, both on the short and the long term, and also think about operations and investment in housing that remains both safe, livable, cost-effective in a changing world. I've got a lot of other resources, a lot of content that could cover a lot of time, probably more than a week or 2 weeks or months worth of time. So if there's interest about what people are doing in terms of best practices spaces or some of the future proofing for phase changing and stuff of that nature, come see me. Be happy to have a conversation with you all. And thank you very much for your attention.
Thanks to all our panelists. I'll ask the first question, and then Sam will be our rover. Question for Becky. Is this a precursor to how do we spend almost $1 billion of PSEF money? Is that...
I really can't speak for the city, and I know there's a lot of pressure on how they're going to dedicate those funds. But definitely, I know in the current plans, being able to provide these kinds of incentives for these kinds of investments is definitely in there. And I think it's just a question of exactly how much.
I mean, that's a broader question to the group too about funding streams is how big of an issue is that to realizing some of these, or are the barriers more technical or finding the right information to make the decisions?
I keep on looking at so much effort that's gone into, especially with the Inflation Reduction Act and the incentives that were included in those. And I've got my fingers crossed that, probably last year I was a little bit more upset that so much of that investment had got into Republican states. But I know that there's over 20, legislators that are trying to hold on to many of those incentives. And we'll see if it still filters through for what's here in Oregon. But just even looking at, what's potentially could come through, through the state and just looking at all those, potential investment dollars for energy efficiency measures. I'm really hoping it isn't delayed any more than it will be, but knowing that it isn't as good a picture as it was even, a couple months ago.
Rita, Eric, do you have any thoughts on that? Is it a technical barrier, or why don't we have more energy efficient building materials everywhere all the time?
Well, for lower embodied carbon building materials, it's not a technical challenge. It's doing the analysis and doing the disclosures and helping people realize that there truly are a lot of best practices and better materials that we can be using to reduce our embodied carbon impact of our buildings.
I think this has been an evolving topic for me and the development teams that I've been working with. I know that, although I have this dream that money grows on trees, it doesn't. But I also know that with the work that we've been doing, it's about educating the folks in terms of the longer horizons and helping them understand if they're putting those investment dollars in now, they're actually going to get a better return on their investment. So with the developers over the course of time, some of those developers have bought into that more so than others. Some of those are a little bit lower and laggards on those fronts. I think in terms of the phenomenal amount of money that we have, like through PSEF, at first it was so much money to think about, and those parties are just figuring out, well, how do we actually get the money out? And now with some of the additions with the SB1 and some of the other programs that are coming to play, those dollars are starting to kind of flow, and those programs are starting to have impact, at least locally. In a larger basis, we're still trying to figure out, like when the federal program went through with the IRA, they had the designs, but they didn't understand practically how we could actually implement it. So for us as the implementers, we had to kind of teach the agencies around that for, well, how does it actually get applied? And we were still writing, or as we say, we were flying the airplane while we're working on the engine at the same time. And so we've now, in the last 18 months, with projects that have gone through that process, we learned a lot. We provided education for future projects. We're still holding our breath a little bit as to how that's going to be in terms of the longer horizons. So,
great. Sam has a question.
Okay. Yeah, a couple of things from online. First, we got a message from Meg Horst, who's the co-chair of the PSEF Advisory Committee, who helpfully notes in the 5-year climate investment plan on table 1, pages 17 through 18, you can see that most of the fund is actually well allocated. We also got a question from Ellen for Eric. We hear from affordable housing providers that the certification process itself is expensive. They might want to adopt the core principles, but not go through with certification. Is Earth Advantage considering the cost of certification related to incentivizing non-state funded developments to incorporate all of the Earth Advantage principles?
So it's a good question. It's also one that is a challenging question in the sense of when we go on work on affordable housing projects, we think about it in terms of lowering kind of the costs as much as we can for those types of services. When we've had projects that have worked on saying they are designing to, but they're not applying that third party kind of initiative. And I like to think that everybody has best intentions of the sort, but fortunately, there hasn't always been the best application of that. So there's a little bit of a hard challenge and truth about kind of working down that line. We're working on right now initiatives to expand our program into providership and allowing for accessibility to more rural and suburban markets. Because one of the biggest cost implications here is boots on the ground and getting people out to those markets. And also there's the design applications as well. A lot of the designs have become more complex, which escalates costs for both the hard and soft pieces. And so I know I'm not exactly answering the question that the person asked, but those are kind of things that can help drive those soft costs down. And I think that's kind of a collective effort that we're all working through together.
If I could just add a little bit, before I joined the DEQ team, I worked as a green building consultant for Brightwork Sustainability for 15 years. And this question came up all the time. And I think it's important to recognize that, there could be a cost premium to do a certification, but it all depends on what are your current practices? How good or how bad are they? If you have some pretty good best practices already in place, you might not have much of a cost add at all to do that certification. And as Eric just noted, good intentions. The accountability that comes along with a third-party certification, it helps you all realize, did you really get what you thought you bought? So that accountability, it's really important. And something that we always tried to do is, meet people where they are, help them realize the good things they're doing, help them realize the things that they could be doing better, give them a good experience and have them come back next time and take it even farther. We can do better.
Yeah.
one more thing I want to say is that we're constantly training the community. So we're constantly training the builders, constantly training the design teams. And so the next project they work on, some of those concepts, they start to get integrated into their future proofing of their designs. And so that cost gap, it starts to get involved. And we would ask, and this is just a general question or request, if you have a sustainability initiative that you're trying to pursue, make certain you involve those people as soon as possible. If we get involved at the permit stage, the cost gap is going to be sizable. If it's involved at the early design stage, then we can actually work with the ship and work on making that a much more viable solution.
Any questions from Jennifer and then Garland?
Hi. So I found the Rita, your presentation about embodied carbon really interesting, and something that I run into in my work as a planner is in cities, it's hard to explain, like when you say, infill development is important, and they say, but what about the tree canopy in my neighborhood? And comparing that like really visual local thing to like the embodied carbon of the asphalt of the new roads that are going to the greenfield development. So I was wondering if you have any like strategies or recommendations for how to help folks kind of understand that better.
I don't think I do. Besides maybe, really showcasing and telling the story of really well done infill. It can be done poorly, right? But I think we need to shine the spotlight and celebrate good examples. But yeah, we need to get better at that.
I will say I'm working right now with DLCD on their housing production strategy and looking at some of the different the tools, actions, and strategies that you can use to develop your strategy, and thinking about the emissions implications of different strategies. And so being able to expressly say, and infill development, and especially if it's transit-oriented development or in places where it's easy to walk, bike, and take transit, and even just the difference between how much single family are you going to build and how much multifamily has a huge like carbon implications. And so we're hoping to be able to illustrate that just a little bit more. And so that's supposed to come out in June.
Hi, my name is Ernestina Fuemayor. I just want to say I work for Salazar Architect, and I was really thank you for Eric Foley, the both projects, the Adelitas and Carter Commons are part of our office. So thank you for showing them. I was really interested in, I also have a specialty in historic preservation. So all these things about preserving the existing building and how that is actually affecting most of the housing storage, like the housing that we have in the city, especially in Portland, is extremely important. I think it's something that gets overlooked constantly. However, when the first talk by Becky was like speaking about the decarbonization and that process, I thought it was so many numbers that were kind of missing into that built environment already existing there. And I wish there was a way that kind of those two things that you guys are doing would kind of compensating some of those numbers. And I just want to know if there's any way, or is there any initiative or anything that kind of combine those two processes, which is one is the use of the utilities and all that, and then is what the existing already embodied carbon energy. Thank you. Sorry, I'm not exactly sure what your question is. Sorry, I was trying to track. If there was any thought about combining some of those two studies into compensating the decarbonization process with also the embodied energy that is being already existing in the building, because the numbers are higher when you have the existing buildings, have a higher number when you have the way to how they are measured into this graphics they tend to be like the ones that have use more energy, right? Because they are older systems and older things. However, the embodied carbon of the building itself, it should be kind of accounted for during that process, but it's not.
Yeah, thank you. It should be, and we as a sector need to get way better at communicating these kind of complex issues and topics, and we need to be better at communicating what embodied carbon is and its significance, especially in our older historic buildings. And we need to be, not just thinking about, we need to be thinking about embodied carbon and operational carbon. And we can walk and chew gum at the same time. And we can use tools. There are modeling tools. There's energy modeling tools for our buildings. We can do a whole building life cycle assessments where we're truly doing the kind of an analogous exercise that we've been doing on our for energy efficiency forever. And there are some really talented firms in town who are doing both of those. And yeah, so crunching the numbers is one thing, and then conveying those in understandable, compelling ways. We've got a ways to go. So let's work together, figure that out.
All right, we're at time. Thank you very much to our panel. Very much appreciate your presence, and it was really enlightening. So lunch in the back.